Hello. In this Labtube, I'll show how you can use elementary row operations to determine if a given square matrix is invertible, and if it is invertible, what is its inverse. The question asks to find the inverse of this 3 by 3 matrix. To be able to do questions like this, you have to follow these steps. The first step is form augmented matrix AI. So you put your matrix, the given matrix, on the left-hand side of your augmented matrix, and on the right-hand side you put the identity matrix of the same order. In this case, it would be 3 by 3. Step 2 is transform this augmented matrix to a row-reduced echelon form. Well, while doing that, you will get a new matrix. You're transforming everything in the left-hand side and in the right-hand side. Then you can apply step 3, which says there is 2 cases. If C is identity, you row this echelon form, you look at the left-hand side, and then if it is identity, that means that A is invertible. And the inverse of A is what you have on the right-hand side of your augmented matrix. So inverse is D. That's case 1. What if C is not identity? In this case, it means that we have a row in the left-hand side which is 0, completely 0. Then you can conclude that A is not invertible. Well, let's apply this here for this example. So first step, form the augmented matrix. Then try to row reduce to find the row reduced echelon form of this augmented matrix. Well, I will start with column 1. Choose one of the entries, non-zero entries, to be your leading one. I have already one here. I choose that to be my leading one. Then make everything else in that entry 0. For example, to make this entry 0, I need to subtract row 1 from row 2 and put it in row 2. This is the notation I'm using. So I have 1, 2, negative 1, 1, 0, 0. Subtract. So 1 minus 1, 0. 2 minus 2 is 0. 0 minus negative 1 is 1. 0 minus 1 is negative 1. 1 minus 0, 0 minus 0. Then I have to make this one 0. To make this one 0, I have to do 3 times of row 1 you subtract from row 3. So I'll do both of them in one step. Well, OK, so I have negative 3 times 1 plus 3 is 0. 7 minus 3 times 2 is 7 minus 6 is 1. Negative 3 plus 3, it is 0. And then 0 minus 3, it's negative 3. And 0 minus 0 is 0. And 1 minus 0 is 1. That's good. Now, my first column is ready. I have leading 1. Everything else is 0. Then I have to move to the second column and start from the other rows. Is there any non-zero entry that I can choose to make my next leading one? Yes. This is non-zero entry. Then you have to put it, change it and put it in the first row that you can put. In this case, I can flip row 1, row 2, and row 3 and bring it up. So I will have 1, 2, negative 1, 0, 1, 0. Oh, I have to write the rest. I have to write the rest. And I have to put row 2 here, 0, 0, 1, negative 1, 0. Very good. Now, this is my leading one, and everything else in that column should be 0. This entry is already 0. There's only one non-zero entry. I have to use that leading one and make it 0. So I will continue here. I will do row 1 minus 2 times row 2. So I have 0, 1. I'm not changing these guys. 0, 0, 1, negative 3, sorry, negative 1, 1, 0, negative 3, 0, 1. And I have to multiply row 2 by negative 2 and add it to row 1. Negative 2 times 0 is 0, add to 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, added to negative 1 is negative 1. Negative 2 times negative 3 is 6, added to 1, you get 7. Negative 2 times 0 is 0, added to 0, you get 0. Negative 2 times 1 is negative 2, added to 0, you get negative 2. Well, that's very good. Now I have a column with one leading one in the right place, and everything else is 0 in that column. Well, I have to move to the next column, third column, and start from the next row. Row 1, row 2 already have leading one, so there's only one non-zero entry here, and I have chosen that to be my next leading one. And now I have a leading one in this column. Everything else in this column should be 0. That means that I have to make this guy 0. To make that 0, I need to row 1 plus row 3. So my row 3 is there. My row 1, row 2 is there. I'm not touching those guys. For the row 1, I have to add this to that. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is 0. Negative 1 plus 7 is 6. 1 plus 0 is 1. And 0 plus negative 2 is negative 2. Well, I found all the leading ones that I can, and I made this matrix row reduced echelon form. That means I'm done with the step 2. So this is row reduced echelon form. Now we have to check step 3. Look at your left-hand side of your augmented matrix. Is that identity matrix, meaning that main diagonal are 1 and everything else is 0? Yes, it is identity. That means A is invertible, and A inverse is nothing but right-hand side of your final matrix, or your row reduced echelon form, which is 6, 1, negative 2, negative 3, 0, 1, and negative 1, 1, 0. Again, very quick wrap up. Form augmented matrix AI. Transform it to row reduced echelon form CD. If C is identity, that means matrix is invertible, and the inverse is the right-hand side. If C is not identity, means that your original matrix is not invertible.